Hey everyone, welcome to The Explainer. Today, we're looking at a massive structural shift happening right now in artificial intelligence. For the past few years, the entire tech world has been totally obsessed with building these giant monolithic AI models. The strategy was pretty simple. Scale up a single system with more and more data, and just throw unimaginable amounts of compute at it. But we're really starting to hit the limits of that brute force approach. We're hitting data walls, the compute costs are becoming absolutely exorbitant, and the returns, well, they're diminishing. So today, we're unpacking a really fascinating new paradigm from Sakana AI called Fugu. This technology totally moves us away from isolated, giant models into an entirely new era of collective intelligence. We're going to explore how bringing specialized models together completely changes the game for performance and, crucially, for reliability.
So what happens when the world's most powerful AI models actually learn to work together? Picture a high-tech, animated school of mechanical fish. Individually, each fish is highly capable, incredibly fast and smart, but they're inherently limited by their own single perspective. Now, what happens when they learn to communicate, delegate, and join forces? This idea perfectly captures the core problem of AI capability limits today. A single model, no matter how massive its parameter count is, eventually just runs out of context. It makes a reasoning error, it hallucinates a fact, or it simply lacks the specific domain expertise required for a complex task.
Okay, let's dive into this. First, consider the old way, the brute force monolith. When you rely on one giant model, you're inherently accepting a single point of failure. It takes massive planet-scale computing to improve it even slightly, and honestly, worst of all, you are entirely locked into one vendor's ecosystem. If they go down, you go down. Contrast that with Sakana's approach, collective intelligence. This is deeply inspired by nature. Instead of building one giant monolithic brain, you utilize a network of swappable agents. Each agent brings specialized skills to the table, engaging in this fluid, dynamic coordination to solve problems together, almost like a hive mind. And that brings us to the star of today's explainer, Sakana Fugu. Think of those individual mechanical fish suddenly merging into a powerful, glowing, super intelligent pufferfish. That's Fugu. But Fugu isn't just another standard model meant to answer your questions directly. It is the ultimate orchestrator. Fugu is a language model explicitly trained to read your query, build a customized agentic scaffold on the fly. Think of that as basically drawing up a custom org chart for every single new problem, and then it delegates the subtasks out to a whole pool of specialized frontier models. It doesn't do all the heavy lifting itself. Instead, it acts as the master conductor. To understand how it actually orchestrates all these models, we need to look at its underlying architecture, starting with the Trinity framework. Imagine these futuristic UI elements locking right into place around our glowing Fugu. The Trinity framework organizes the chaos by assigning three distinct, highly focused roles to the models in its pool. First, you've got the thinker, then the worker, and finally, the verifier. Instead of just throwing a massively complicated prompt at a single model and, crossing your fingers, Trinity breaks the problem down. It assigns these specific roles to different models to ensure incredibly deep reasoning and rigorous accuracy. And this brilliantly illustrates how this plays out in practice. Say a complex user query comes in, maybe a really tricky, multi-layered financial depreciation calculation. The orchestrator doesn't just immediately generate a single answer. In turn 1, it assigns a thinker to map out a clear step-by-step plan. In turn 2, a worker model is brought in to execute that exact plan. And finally, in turn 3, a verifier steps in to double-check the work, actively catching any subtle errors the worker might have missed. It is a continuous, turn-by-turn conversation, and it's all happening at absolute lightning speed across the network.
Building on that, Sakana developed the conductor framework, which actually powers their most advanced systems. Using reinforcement learning, the conductor essentially learns natural language coordination strategies. Through millions of cycles of trial and error, it figures out the absolute optimal management strategies for completely different types of questions. Here's the step-by-step workflow. First, it reads the input query. Second, it builds a completely tailored agent scaffold, dynamically deciding the very best team structure for this exact problem. Third, it delegates the subtasks to the right specialists. And fourth, it verifies the work and synthesizes it into one clean, final answer for the user.
Because different tasks obviously require different levels of coordination, Sakana offers the system in two main variants. On one hand, you have standard Fugu. This model is incredibly snappy, optimized for low latency and everyday interactive use, kind of like a fast-paced chatbot. It typically uses single worker dispatch to keep things moving rapidly. But on the other hand, you have Fugu Ultra. This is the heavy hitter. It trades a little bit of that raw speed for maximum answer quality. Fugu Ultra coordinates a deep, complex pool of agents to solve incredibly hard, multi-step problems that would completely break a normal model. To see just how powerful Fugu Ultra truly is, we have to look at this benchmark, 95.5%. What does this actually mean? Well, this is Fugu Ultra's state-of-the-art score on the GPQA Diamond benchmark. For context, this isn't just standard trivia. GPQA Diamond is an exceptionally difficult, notoriously brutal benchmark explicitly designed to test graduate-level scientific reasoning. We are talking about questions so incredibly hard that even highly educated human experts struggle to answer them. By combining the unique strengths of multiple frontier models, Fugu Ultra pushes well past the limits of any single system currently on the market. It's honestly amazing. Now, what's really interesting about this slide is how this collective intelligence translates directly into real-world software engineering. We're looking at data streams for SWE-bench Pro, a benchmark that tests a model's ability to solve real, messy GitHub issues. GPT 5.4 comes in at a solid 51.2%. The standard fast Fugu model hits 59%, but Fugu Ultra, utilizing its full multi-agent orchestration, leaps to a staggering 73.7%. That's an unbelievable jump. It decisively proves that when coding tasks get deeply complex, having a tightly coordinated team of specialized models is vastly superior to relying on a single, isolated model. But we all know benchmarks only ever tell part of the story, right? What you should really take away from this is the real-world impact. In messy, long-horizon tasks where single models simply run out of context and crash, Fugu thrives. In a recent test tasking AI to solve 300 Rubik's Cubes, Fugu solved all 300 without breaking a sweat, while single-model competitors literally crashed and burned before finishing just one. In code reviews, early users reported Fugu surfacing over 20 legitimate bugs, where standard tools only found 3. And in auto research, Fugu Ultra successfully executed 14 solid hours of autonomous multi-step scientific work, all starting from a single prompt. No way a monolith pulls that off alone. But the underlying technology is really only half the story. We also have to look at the massive operational reality of AI today. The sources highlight a major geopolitical and infrastructural vulnerability. Sakana AI argues, and I quote, "Relying on a single company's APIs for critical infrastructure, finance, or governance is a material vulnerability." They're pointing out that in today's highly volatile world, depending on one single vendor means your entire AI infrastructure could literally just disappear overnight. This could happen due to sudden export controls, shifting corporate policies, or even just massive API outages. So how exactly does Fugu address this massive risk? By securing what is called AI sovereignty. Because Fugu is a dynamic orchestrator built on top of a diverse pool of swappable agents, it completely eliminates single vendor dependency. If one major provider goes down, or if a specific frontier model suddenly gets restricted in your region, Fugu doesn't break. It dynamically routes around the obstacle, automatically assigning the crucial tasks to other highly capable models in its pool. It acts as a brilliantly resilient, highly practical hedge against the increasing concentration of AI power. We've covered a lot of ground today, from the Trinity and Conductor frameworks to beating frontier models and securing true AI sovereignty. It completely challenges the bigger is always better narrative we've been fed for years. So I want to leave you with this final provocative thought. Does the future of AI belong not to the biggest model, but to the best conductor? When you look at the incredible, resilient results of collective intelligence, it certainly seems like orchestration is the true next frontier. Thank you for joining me for this explainer, and keep exploring the fascinating world of collective AI.